Hi everyone, we are Team PulseAI. Our team members are Jackie, Oliver, Schumann, Wenlu, Jenny, Will, and me, Caleb. We are building PulseAI CRM, a chat-based AI-native CRM that turns scattered messages and meeting notes into customer memory for B2B sales team. Here is our team list. Schumann is our tech lead, driving the MVP architecture, and I'm the engineering manager, keeping the team coordinated. Now I will hand over to Jenny to show who PulseAI is for.
Hi everyone, I'm Jenny, and I will walk you through who PulseAI is for and the key use cases. First, who is PulseAI? We are focused on B2B account executive managing a small number of high-value accounts with long sales cycles. Imagine an AE selling enterprise software to QBE insurance. One deal, many stakeholders, and months of conversations. The problem is that real custom knowledge lives in emails, meeting notes, and chats, not the CRM. Traditional CRM asks AE to manually turn all of that context into fields. They often don't, so the CRM gets stale and important context gets lost. That's why we focus on 3 moments: capture, recall, and decide. First, capture. After a call, the AE pastes an email or meeting note into PulseAI. AI identifies what changed. The AE confirms it, and it remembered, no forms. Second, recall. Before a meeting, they can ask, how is the QBE deal going, and what's blocking it? They get the answer with original evidence. Third, decide. PulseAI suggests the next action, but the AE confirms it before anything is saved. In short, capture what happened, recall why it matters, and decide what to do next. And now we will show you how we translate these use cases into our MVP feature set.
Our MVP delivers one complete and trustworthy customer memory loop. First, a sales representative selects a customer. They can ask a question or paste a plain text email or meeting note. PulseAI preserves the original text and extracts needs, concerns, decision makers, risks, and opportunity changes. It then presents the existing value, the proposed update, and supporting evidence. The user confirms or rejects each important change before it enters the tiered memory. The salesperson can then ask about deal status, blockers, recent interactions, delays, or the next step. PulseAI uses agentic RAG and progressive retrieval. It checks the customer summary first, then retrieves detailed memory and raw evidence only when needed. Each answer is concise and linked to its original source. Recommended actions also require confirmation before they are saved. To keep the MVP achievable, it supports plain text input and one active opportunity per customer. Vector search, file uploads, integration, and graph RAG remain future extensions.
I'm Schumann, and I will introduce our technical solutions. The core of our architecture is to manage information flow between short-term memory and tiered long-term memory. At the top, users interact with PulseAI CRM through chat and visualization. Requests are handled through the HTTP API with SSE streaming responses back to UI. User authentication built via Superbase auth. At the center is the core agent orchestration layer built with the Cloud Agent SDK. We will build a single main CRM agent to understand each request, decide what action is needed, and generate the response. It also maintains the short-term memory, containing the current conversation, task, and retrieve the context. The agent calls Cloud LLM for extraction, reasoning, and response generation. This layer contains two orchestrators. The retrieval orchestrator controls read decisions, while the memory orchestrator coordinates memory updates. Both call the tools layers to perform the actual retrieval and memory operations. The data layer stores three-tier long-term memory. Tier 1 stores the current customer profile summary. Tier 2 contains consolidated domain knowledge and insights, for example, opportunities, risks, stakeholders, and decisions, etc. Tier 3 preserves the original text, evidence, and metadata. For the MVP, these tiers are primarily stored as text in Postgres, with full text search for evidence retrieval. PG vector and embeddings are reserved for extension. The diagram on the right explains the two core data flows. Reading moves from top to down. The system first reads the summary, then expands to domain memory if the context is insufficient, and retrieves raw sources only when the evidence is required. Once the sufficient information is found, the retrieved context is returned to the main CRM agent and added to STM. Writing moves from bottom to up. The system first preserves the raw sources, then extracts, confirms with users, and consolidates domain updates. It refreshes the summary only when the top-level information changes. Therefore, reading stops at the earliest sufficient tier, while writing propagates upward only when the next tier is affected. Overall, this architecture is designed to balance retrieval efficiency, evidence traceability, and controlled memory updates. Application logs and deep eval will help us validate these assumptions during the MVP. In terms of our tech stack, for the front end, we use Nest.js, React, and TypeScript with Tailwind and Chassis UI. The Vercel AI SDK supports the streaming chat experience. For the agent and API layer, we use Cloud Agent SDK to build the main agent. Python and the Fast API provides the backend API and SSE streaming. For data and retrieval, Supabase provides Postgres and authentication. Postgres full text search supports evidence retrieval in the MVP. PG vector fast embed, BGE embedding modules are reserved for later version. For quality and delivery, Pydantic and Zod provide validation. PyTest, VTest, and Playwright support testing, and DeepEval evaluates AI behavior. The application is containerized with Docker and deployed on render. Our main MVP principle is the simplicity. Basically, one managed data platform with no separate vector database, Redis, and microservices.
Thanks, Schumann. So I will continue to walk you through our milestones and deliverables. Our build runs in 2 phases across 12 weeks. Phase 1 is our core MVP loop. In weeks 1 and 2, we'll set up foundation, log our tool contracts, run an agent tool call spec, stand up Supabase database, and deploy the full stack end-to-end on render, proving the architecture connects before we build anything real on top of it. Weeks 3 and 4 brings us to milestone 2. Raw customer nodes are captured, classified, and written into the long-term 3-tiered memory. Capture raw to text in tier 3, and then consolidate facts up to tier 1. Weeks 5 and 6 brings us to milestone 2, progressive retrieval from tier 1 summary down to tier 3 domain memory with an evidence check. plus automatic retrieval added over our tier 3 raw text. That's also our September 24th demo endpoint where we freeze the feature set for phase 1. Phase 2 is about hardening and extending that loop. Weeks 7 and 8 are milestone 3. The system is validated with an automated test suite and scored evaluation set. Weeks 9 and 10 are milestone 4. We'll add a structured schema and structured retrieval path directly alongside our tiered memory. And by weeks 11 and 12, we'll run broader user testing against our success metrics and ready for our final demo on November 5th.
Hi, my name is Oliver, and I will be talking about the risks and mitigation plans. The first risk we have identified is the timeline, because our project scope is quite big and we only have 8 weeks to implement it. So we need to control it very strictly. We have split all the features into 3 levels, P0, P1, and P2. P0 is the must-have. We will deliver this first. And for some more difficult parts, like the knowledge graph, we will push it to later, only after we pass the week 5 gate. The second risk is about data integrity. Our system writes to our customer memory, so there is a risk that maybe it saves something wrong or duplicated. To prevent this, every update must come with evidence and a confidence score, and the user must confirm before we write. And when there is a conflict, we never overwrite. Risk number 3 is about the quality of answers. If the AI gives an answer that is not grounded, the user will lose trust very fast. So for every answer, we must show the original source. If the evidence is not enough, the system will not guess. It will just tell the user honestly. Risk number 4 is about cost and infrastructure. The large language model has a rate limit, and the token cost can go up very fast. So in this case, we will use caching and batching. And actually, our tiered memory design also helps to reduce the tokens. For the less important task, we can also switch to a smaller model. So these are the identified risks and mitigation plans. Next, I will hand it over to Jackie to talk about the last part.
Finally, how can we know this project works? We design our metric backwards from where a system like this actually fails. First, abstraction. For example, the email or the meeting note are stored as the raw data in tier 3. So nothing is lost there. The risk is what we extract from it into the tier 1, like the stakeholders, the date, the risk, and where the opportunity stands. So at least 85% of that had to be correct. Second, answers. Our MVP is scoped to find an opportunity forward. So the questions are the ones like the salesperson asked for the opportunity view, like where does this view stand? And what blocking it? Why? And what should we do next? So this part at least 80% correct. The third one is evidence. Every answer must open the original notes it comes from, at least 90% of the time. But for the question without evidence, the answer is something like, I'm not sure about this, is acceptable. And then we also hold one number, we hold at 0. So nothing enters the customer memory from the tier 0 to the tier 3 without the user confirming it, and never against the wrong customer. So we measure on the fixed set. So we will have the 20 pieces input, 20 questions, and human hard written is a good answer. We store by hand at every milestone. So the success is measured, it's not claimed. So that's all of the presentation. Thank you for your time. And we love hearing your feedback. And we are happy to take any questions. Thank you.